Hello 8th grade, this is Mr. Rogers and you're watching the video lecture for section 3-2 on acids and bases in solutions. So, this first page guys, we're going over our lesson objectives. You do not write this down, but kind of what you should know by the end of the notes on what are our goals. So our lesson objectives. The first one is to identify the ions formed when acids and bases dissolve in water. Secondly, we want to be able to explain how the pH scale works and how it's used. And finally, describe a neutralization reaction. Those are the three things by the end of this lesson I hope you guys have learned. So here we go. First thing is about acids and bases. And this is more getting to nuts and bolts of what makes an acid or a base a base. We had some basic descriptions in our previous notes, but in this one, really more what's going on inside of an acid, what's happening that makes it an acid. Well, what happens is all acids have hydrogen ions, these H+ ions, and they're really the key to how acids react. And so kind of a new definition, kind of reinvent our definition for acids, would be any substance that produces H+ ions. Really, it should be in water also. Form these H+ ions in water. Because what happens is, once it reacts with water, those ions separate out. They're kind of floating around looking for something to react with. So in water, they form H+ ions. So on the other side of that, we have bases. And so this is why we kind of consider acids and bases opposites, is the idea that acids form the H+, the positive ions, and bases form negative ions. So what we get here are these hydroxide ions. So a hydroxide ion is a negative ion made with oxygen and hydrogen, so it's negative. A base is any substance that produces the OH negative ions in water. So acids tend to have those H+ ions, bases tend to produce the OH negative ions in water. So when we put bases in water, they form OH negative ions will be floating around in that solution of water and the base. So that's what we consider acids and bases to be opposites, is they do react differently, but also they form different types of ions when they're put in water. What we're going to do is take a real quick look, this kind of a simple diagram right here of the pH scale. And the idea is that here's 7, that'd be neutral. High pH, so we'd have like a 14 over here. And maybe on this side, low pH, this would be 1. And so the closer you get to 1, the more of these H+ ions are going to be forming. It'll be a very highly concentrated number of H+ ions in solutions that are near. When you're down here near 1, you have a very high concentration of H+ ions. When you get up here in 2 and 3, there's a less concentrated solution of H+ ions. When you're actually near 7, you actually have kind of equal amount of hydrogen, H+ and OH negative. And as we go the other way, we have more and more of these OH negative ions in the solution. So when we get close to 14, that solution is going to have a very high concentration of this OH negative ions. We almost completely separate out into those OH negative ions. And so that's how we kind of idea of what does this pH scale mean with our next step here. So this pH scale is a range of values from 0 to 14. We talked a little bit about it in our last notes also. And what it's really focusing on is that the amount of hydrogen ions. And you can see from the picture, I'm going to jump back to the picture from before, is that when we get closer to 1, we have a lot of H+ ions and just a little bit of OH negative. And when we go the opposite way, we have a lot of these OH negative ions and just a few H+ positive, very few left by the time we get to 14. So it's almost always OH negative and no H+ is left when you get to 14. And same is true when you get down to 1 or 0, is we have almost all H+ ions and no OH negative left. Where if we are at 7 here in the middle, there'd be a balance between the H+ and the OH negative ions. So a low pH tells you that the concentration of hydrogen ions is high. It's kind of weird to think about. So the lower I go, the higher the concentration. Yes, the lower you go on the scale, the more H+ ions, the higher the concentration is, the more they're packed into that space. On the opposite side of that, a high pH tells you that the concentration of hydrogen ions is low. So as you get closer and closer to 14, there are fewer and fewer H+ ions and more OH negative. But the scale is kind of determining the H+ ions is what it's focusing on. So let's take a look at the scale again. And here, remember, it goes from 0 up to 14. And actually 7 is there in the middle. That's actually neutral. So pure water, distilled water, no minerals in it, anything like that, would be considered neutral. That's why water is the universal solvent, is because it is neutral. But our saliva, blood's actually probably slightly acidic there. Milk is actually slightly acidic too. So on this scale here, bread's actually done this way, potatoes. A lot of your fruits and vegetables tend to fall in that 3, 4, 5 range, so they're acidic. Think about OJ, or I think even go down to 1 or 2, you get down to like lemon juice. That's pretty acidic stuff. Hydrochloric acid, that's what's pretty potent stuff. You find that normal stomach acid, that also a type of hydrochloric acid is in there. So this is when we get that very acidic areas we get down toward here. On the other end, we get our basic substances, or also called alkali substances. We get things like baking soda, borax, antacids, ammonia, milk of magnesia. So sometimes we get our antacids fall in this category. Also cleaning supplies, so like soap. So here's our detergent, phosphate detergents, baking soda. So all of our cleaning supplies tend to fall in this category over here. Bleach is very basic. Drain cleaner would be down here also. Sodium hydroxide is a very basic substance that will be on here too. So you can see how these kind of separate out between very acidic with lots of H plus ions, and over here very few H plus ions but a lot of OH negative ions. And finally today, guys, we have the idea of a neutralization reaction. And this kind of combines the idea of those acids and bases. So a neutralization reaction is a reaction between an acid and a base that produces a mixture that is not acidic or basic. It's neutral, hence the word neutralization reaction. The products are water and an ionic compound. And we say ionic compounds. Ionic compounds are a combination of those, remember, metals and nonmetals. A lot of times that's the positive and negative ions coming together. So that'd be those H plus ions, maybe the OH negative ions coming together. Those oppositely charged ions coming together. And so you form, say, ionic compounds, but it's water and some type of a salt. All right, so we're going to stop here, 8th grade. I thank you guys for watching, and we'll see you along the way. Thank you.